Hi everyone. So today we're going to work on solving a system of linear equations by graphing. So I guess we better figure out what exactly is a system of equations. So we're going to define that as a set of two or more equations. So let's write that, a set of two or more equations. Okay. Now we're going to specifically look at a linear system. So let's specify that we're going to look at linear systems, which means that we're looking at linear equations only right now. Okay. All right. So that means our system is going to be a whole bunch of y equals mx plus b's. Okay. They're going to be a whole slew of lines. All right. Now, how are we going to solve this by graphing? Well, we are going to be looking for, all right, is that we're going to graph all of the linear equations meaning we're going to go y equals mx plus b, and we're going to graph all of them, okay, on the same coordinate plane, on the same xy, on the same coordinate plane. Okay. And what we're going to be looking for is an ordered pair that makes all the equations true. Okay, now it may not just be an ordered pair. It's all the values that make this equation true. So sometimes it might be an ordered pair. Sometimes it might be a line. Okay. Sometimes there's no solution. Okay, so we have to be aware that there's actually three different types of answers. Okay, so what we're going to do is we're going to demonstrate all three answers. So there are three solutions. So we're going to graph these two equations and take a look at their answers. Okay, so let's start with the first one here. We're going to state our m, which is 1, and our b, which is 2. Okay, so we're going to start at b. Go up one, right one. Okay. Okay, there it is. Let's change the color here. And here we're going to go, our slope is 3, and our b is equal to -2. Okay, so we're going to start at -2. There it is. All right, so we can see that these two lines intersect right here. And that is the solution to the system, because that ordered pair, which is 2, 1, 2, 3, 4, 2, 4, that is our solution, is on both lines, which means it satisfies or makes both equations true. Now we can check that. If I take it and put it in the one that's blue and go 4 equals 2 plus 2, right? Cha-ching. So all I'm doing is putting the ordered pair into the equation. Okay. Cha-ching, makes it true. Now, since this is a single ordered pair that makes the equation true, it has a name. Okay? So we have an ordered pair that makes the statement true. So we're going to have this called independent. This is an independent system. Because it has a solution. One solution. One ordered pair, we're good to go. Okay? All right, let's try the next one. All right, so we're going to need to do a little work here to get our y equals mx plus b. Okay, so we're going to divide everybody by 2. Remember, there's always a 1, so we're going to make that 1/2 plus 1. Okay, so we're going to graph it. There it is. Okay, we're going to do the same thing with our second equation. It's already y equals, so we're going to go m equals 1/2, b is equal to 1. All right, I already noticed something peculiar about this pair of equations because they both have the same slope. Okay? And they have exactly the same y-intercept. Oof, they're the same line. So how many ordered pairs make that statement, like both equations, true? Is it's infinite. Okay, so this particular has infinitely many. Solutions, because any ordered pair on one line is going to make the any ordered pair on the other true. Okay, so this is called a consistent system. I probably just spelled that wrong. Oh, I had an extra T in there. Let's try that again. Okay. Sorry about that. There we go. Okay, and that means it has infinitely many solutions. Many ordered pairs make both equations true. All right, let's try this one. Okay, again, we're going to have to do a little bit of work. So we're going to do m equals 2 and b equals 2 for my blue line. There we go. Okay, and let's take a look at the other line. All right, see how I have to do a little work here. I'm going to distribute that 2. I'm going to add that 3. All right, so here's my slope is 2 and my b is 11. I know I think we're off the graph with that. 2, 3, 4, 7, 8, 9, 10, 11. So we're just going to have a dot up here. And our slope is 2. I'm just going to go on this side of it. Oh, look at this. They are parallel. So there's no ordered pair that make both equations true because they're not intersecting. So it has no solution. Okay, so this type of system is called inconsistent. Because it has no ordered pair that's going to make both equations true at the same time. All right, so let's look at these again. If we have a point of intersection, this ordered pair, if I put it in, makes both equations true, is called independent. If it's the same line, the two equations represent the same line on the graph, that's called consistent, meaning there's infinitely many ordered pairs that make this statement true, or makes the equations true. And if there's no solution, meaning they have the same slope, different y-intercepts, they're never going to intersect, meaning there's no ordered pair that's going to make both equations true at the same time. It's called inconsistent. All right, so let's try this. So we're going to solve these by graphing, and we're also going to talk about what makes the equation true. All right, so we're going to graph y equals 2. Remember we talked about that? It is a horizontal line at 2 because we're intersecting the y-axis. Okay, we're going to go to this one. Our slope is -2. Our y-intercept is 8. Now remember, we're looking to see where it might cross the x-axis, cross the other line. Looks like it's right here, but we're going to draw the line. There we are. All right, so there is a point of intersection. Oops, not there. It's right here. So we're going to label that. That's 3, 2. So my answer is 3, 2. So if I put 3 and 2 in for x and y in both equations, we're going to get a true statement. And remember, we called this independent. Okay. All right. I want you to pause the video and try the next one on your own. Okay. Here's what I got for the second one, and I forgot to label this one independent. Okay, so there is a point of intersection. I had to go to 12 off the graph. Do the best you can with that. All right, let's try another one. Oops. Oh, I want to scroll to this one. Okay, so this one was a little tougher, so I'm going to need to do a little work to get our y equals mx plus b. So I'm going to add the 12 and subtract the 3x at the same time. And now I'm going to divide everybody by 6. And remember, we can make that -1/2 if we choose to do so. Okay, so our slope is -1/2. And our y-intercept is 2. Okay, so I'm going to come over here and I'm going to graph that. Down 1, right 2. There we go. Okay, now we're going to do the other one. Okay, I'm going to have to get y by itself, so I got to subtract that x. Divide by 2. Remember, there's always a 1, so we're going to write that as -1/2. Okay, so we're going to start at 4. Oh, look at that. They're parallel, which means that they're never going to intersect, which means that that is not going to work. Just did not like that line, did it? There we go. They're never going to intersect, which means that there is no point of intersection, which means that we have a no solution problem here. Okay, which means that we have an inconsistent system. Because there is no solution. All right, guys, pause the video and try number 3. All right, so here we go. Again, we find this point of intersection, and we're going to say, again, this is independent. All right. Okay, guys, so hopefully we're going to be able to graph lines. We're going to find on the same coordinate plane, determine if they intersect. If they do, what is the ordered pair? Because that ordered pair makes both equations true. Put them in, we get true statements. All right, if they don't intersect, they're parallel, then there's no solution. Remember, that's called an inconsistent system. And if they're the same line, which is called consistent, there are infinitely many solutions. All right, that's it for today. You do have solving systems by graphing in your homework folder. Have a great rest of your night. Please be safe out there, and I'll talk to you again real soon.